To access what's in this lesson, you're going to need to know how to write numbers as the product of primes, and how to find the LCM, lowest common multiple, for pairs of numbers. Good? Now, finding the lowest common multiple for 3 and 5 is a piece of cake. Easy times tables and a low lowest common multiple. But what happens when we need to find the lowest common multiple for some more awkward numbers? Let's say 27 and 42. Am I going to, without a calculator, go through the 27 and 42 times tables? No. Instead, I can use prime factors to figure out the answer. Using our prime factor trees, we know that 27 is 3 times 3 times 3, and 42 is 2 times 3 times 7. With the highest common factor, all we had to do was find the matching numbers. Here though, we have to feed all of this into a Venn diagram. Now, if you've never come across a Venn diagram before, the basic principle is that information about 2 or more different things is split into circles, with any information that's shared between the subjects going into the overlap in the middle. We'll look at this in a bit more detail at another time though. For now, let's put these prime factors that we have into one of these Venn diagram thingamybobs. We can see that both 27 and 42 share 3 as a prime factor, so that can go in the overlap. We've only written it once, but it counts for both camps. And left for 27 are 2 more 3s. These can go in the other part of the 27 circle. And left for 42 are 2 and 7, and these go here. All that's left to do now is to take all of these prime factors in the diagram, and just as we did with the highest common factor, multiply them together. Now, we already know that these factors multiply together to make 27, 3 times 3 times 3, so we just need to multiply that by the 2 and the 7. So 27 times 2 is 54, and 54 then multiplied by 7 is carried to 378. So 378 must be the lowest common multiple. And to prove it, here are some times tables I worked out earlier. 378 is the lowest number in both of those lists. Lowest common multiple. So we wrote the numbers involved as the product of prime numbers. We then put these prime factors into a Venn diagram with any that matched going into that overlap. And then we multiplied together all the factors in that Venn diagram together, and that gave us the lowest common multiple of our complicated numbers. Go back and watch all this again if you need, but if you do not, have a go at these. 36 and 24 as the product of primes are written below. Place these factors into the Venn diagram, remembering a matched factor only needs writing once in the overlap, and multiply what's there together to find the LCM of 36 and 24. You can use the accompanying sheet or draw out your own Venn diagram. Once you've done that, see if you can find the lowest common multiple of 15 and 18. Pause the video and restart once you're ready. Answers are coming in 3, 2, 1. Okay. We have 2 matching 2s and a matching 3 in the prime factors of 24 and 36, so these go into the overlap. This leaves an extra 2 in the 24 section and a 3 in the 36 section. All of the 24 section multiplies to make 24, so all that's left to do is multiply it by the 3 to get 72. 72 is the lowest common multiple of 36 and 24. If you've seen M008, you may also have noticed that this overlap, which features all the matching factors, also represents the HCF, the highest common factor. In this case, it's 12. 12 is the highest common factor of 36 and 24. For question B, 15 is 3 times 5 and 18 is 2 times 3 times 3. The matching 3 goes into the overlap and we fill in what's left. 3 times 5 makes our 15, and then this times the 2 and the 3 gets us to 90. 90 is the lowest common multiple. As always, if you are confused with anything you've seen, you can always watch the video again or find a teacher to help you out. If you're good though, I feel I've shown you everything that you need now for this particular unit of work. All that's left is to see if you can take the skills that you've developed and apply them at the right time in the right place for questions that are asked. Have a go at the Big Brain Buster.